You haven't heard of proteins,
Oh,
lipids,
yes.
carbohydrates?
Yes.
Okay, so where do we find those?
In our body.
In our bodies, that's right. And our body needs all these molecules to function. So what do you think is in these molecules that help our body function? Raise your hand. Yes? What's the most common atom in organic molecules?
Protein.
Not proteins, but carbon. Carbon makes up most of our organic molecules. So anyway, today we're going to investigate the macromolecules that are in our bodies and the functional groups that help our bodies function. So today's lesson, there are 4 macromolecules in the body that are essential to human life. These macromolecules are composed of hydrocarbon chains and functional groups. We're going to describe and demonstrate the structure of the 5 functional groups. So the functional groups we're going to discuss today are, and I want you to write these down. I want you to take notes because you're going to be assessed on them later. So the 5 functional groups are, write these down, methyl, okay, hydroxyl, carboxyl, amino, and phosphate. Do any of these sound familiar to you?
Hydroxyl.
Hydroxyl.
Because of hydroxychloroquine or whatever it's called.
Right. Recently on the news, we've heard a lot about hydroxychloroquine. I think it's hydroxychloroquine. I'm not sure. But have you heard of aminos? What about amino acids? Aminos make up protein. Amino acids make up protein. Okay, so before we get into these functional groups that are in our macromolecules, we are going to discuss and review properties of the carbon atom, because these properties are what make the carbon atom such a backbone for organic molecules. So does anyone remember this symbol for the element of carbon? What would you think if you just took a guess? Just one letter.
C.
C, right. So we write carbon with a C. That is the symbol for carbon. So why do you think that carbon is the core of these organic molecules? Well, it has to do with the electron configuration of carbon. Remember that on the periodic table, carbon has 4 valence electrons. So I'm going to draw this as a Lewis structure. So if these were 4 valence electrons around carbon, we would need, carbon desires those electrons to be in pairs, right? So there are 4 spaces for other electrons to bond with carbon. So carbon loves to share these 4 electrons and form covalent bonds. So it likes to bond with other carbon atoms easily because other carbon atoms guess how many, so other carbon atoms can bond with this pretty well because they also have 4 electrons. So they just come right in here. So carbon also bonds really well with hydrogen because hydrogen only has 1 valence electron. So these hydrogens can easily just come right in here and pair with these carbon's valence electrons. So as we'll see in today's lesson, carbon also bonds to share with oxygen, nitrogen, and other atoms. So sometimes these other atoms will change the structure of the carbon chain and cause like a dipole moment, which a dipole moment just means that it bends the molecule. So the molecule has now not just a straight carbon chain, it has an angle to it. So today we're going to talk about, so just any questions about carbon? So remember this structure for carbon, and that it has 4 valence electrons, and it really likes to bond with hydrogen and other carbon atoms. It likes to form covalent bonds, which means it's sharing its electrons. Okay, so now that we've reviewed the chemistry of the carbon atom, we will learn about the functional groups that we were talking about. So does anyone have an idea about what a functional group is? So what does it sound like? Lou?
A group of functioning things.
So yeah, a group of functioning things. It could be molecules that function means it has a specific duty, right? So they do something in these macromolecules. And a functional group is a group of atoms that are covalently bonded and usually function as a unit in chemical reactions. So let's write that down. Functional group So a functional group, they're atoms that are covalently bonded. So we're going to write covalently bonded. What else? They function as a unit. Something else about these groups is they usually like to stay together. They're BFFs. They don't like to leave each other. So that's why they usually function as a unit. They stay with the molecule as a unit, they leave as a unit. So they're BFFs. Okay? Alright. So write that down. Now we're going to go over each individual functional group that we stated at the beginning of the lesson. Alright, so we have methyl. So methyl you can write it normally like C and then H3, okay, because it has 3 hydrogen atoms bonded to the carbon, and then it's usually bonded to probably another carbon atom. So methyl is the basic unit of hydrocarbons. 3 atoms share an electron with each of the 3 sides of the carbon atom. And usually there's another carbon atom attached right here. So let's draw, what does that look like when we draw the structure? You're going to be having to name these and draw these and make models of these later, okay? So we really get a good idea of what these structures look like. So we have a hydrogen atom, so we have a carbon atom, a central carbon atom. I'm going to erase this part. We have 3 hydrogens around that central carbon atom because this carbon electrons, and this is probably connected to another carbon, but I'm not going to draw that because I just want you to know the structure of this functional group, methyl. So methyl is CH3. Any questions? Okay, let's move on to hydroxyl. Okay, so hydroxyl is OH, oxygen and hydrogen. So hydroxyl is the simplest functional group that contains oxygen. So let's write that, OH. Okay? So hydroxyl groups make a molecule polar because of the high electronegativity difference between the oxygen and the hydrogen. So when you see, so we know water, and water is polar because they have two hydrogen atoms and one oxygen atom. And that oxygen atom, those spare electrons repel the others, so it bends the molecule. Hydroxyl groups are also found in alcohols. So if hydroxyl groups make a molecule polar, what do you think that means for alcohols and other molecules that contain hydroxyl groups? So hydroxyl is like water. It has the same OH. It has the same polarity as water. So that makes hydroxyl groups water soluble.
Plasma?
That's what plasma is a different molecular structure, but it also, I believe, is water soluble. So anything that can dissolve in water is water soluble. Okay?
Plasma.
So let's see, let's do, pay attention please. So we have, let's write this hydroxyl group connected to methyl. Okay, so we have CH3, and then we're going to have this hydroxyl group out to the side. So this is the hydroxyl group, and did you notice this is methyl? Okay, so let's move on to the next one, which is carboxyl. What do you notice about the name? And sounds like, yes, there's carbon, but there's also, what did we just talk about? Hydroxyl, right, has the same ending sound. So carboxyl, the formula is OCOH. Okay? So carboxyl groups contain a carbonyl and a hydroxyl group. The oxygen atoms make this molecule highly polar, okay? And also highly reactive. Okay, so what does a carboxyl look like? What does a carboxyl group look like? So we have our carbon atom right here, okay? And then we're going to have a hydroxyl group on one side and a carbonyl group, which is this double bonded oxygen and usually another functional group. R means another group. R is another functional group. Okay? So that is what the carboxyl functional group looks like. The double bonded oxygen with the carbon, and then the hydroxyl group here. So you can remember that by thinking carbonyl and hydroxyl, or carboxyl. Okay, so let's move on to aminos. So, amino groups readily form hydrogen bonds with water. They're also weak bases. So when you add them, they increase the polarity and the reactivity of the molecule. So let's draw the amino group.
What's the symbol?
So here it is. So we have another functional group out here. We have, this time we have a central nitrogen. Nitrogen is the main atom of an amino group, okay? And this would probably be a carbon. So we have nitrogen, and it is bonded with 2 hydrogens. Okay, again, it's highly polar, increases the polarity and reactivity of a molecule. Okay, does everyone have that down?
Mm-hmm.
All right, so let's move to the last one, which is a phosphate group. Okay, so phosphate groups are highly acidic, and they are highly reactive because they have 4 oxygen atoms. Phosphate is ionic in nature, but I'll draw the structure and you will see, before I make the next statement, why I'm going to say what I'm going to say. You think, so far we've had these oxygen atoms that make things what? What do we call it? Polar, right?
Mm-hmm.
So these oxygen atoms have made things polar because they put an uneven charge and they bend the molecule. So what if I were to tell you that phosphates are not polar? They're non-polar. So why do you think that if phosphate's not polar, why do you think phosphate's not polar even though it has all these oxygen atoms? What do you notice about oxygen atoms? So we saw in carboxyl, look at your carboxyl drawing. There's angles, right? There's angles. There's angles here, but they're even, right. They're evenly distributed, so the charge is evenly distributed, so there's no angle that causes a dipole moment, okay? So there's no it is non-polar. Okay, so carbon's affinity for covalent bonding leads it to form these large macromolecules that we discussed at the beginning of the lesson, the lipids, the DNA, RNA, what else, Luke? I said lipids, DNA, RNA, what else is in our body? Protein and fats, lipids, right. So these macromolecules are so important that we cannot live without them. So these are essential for living. Okay, these are essential functional groups because they help make up these macromolecules. So right now, I'm going to put on a PowerPoint, and I want you to try to identify these functional groups. Use your notes. We're going to try to identify the functional groups as I go through carbohydrates, lipids, proteins, and DNA. Okay. Okay. So functional groups essential to human functioning are those that we find in macromolecules. So the first one we're going to talk about is carbohydrates. Carbohydrates, what functional group do you notice the most in carbohydrates?
Carboxyl.
I see a carbonyl. What about this? So let's look. Let's look at the next slide and we'll see. What is OH?
Hydroxyl.
Hydroxyl, right. So there's a lot of them. There's a lot of hydroxyls, right? So the hydroxyl groups in the carbohydrates make this molecule polar. Okay, this is fructose. This is one of many sugars that we ingest. This is fruit sugar, and it has these many hydroxyl groups. Okay, so let's go on to the next macromolecule, lipids. So lipids are these long hydrocarbon chains, and this one is palmitic acid. What is it about lipids where is the functional group in lipids?
Methyl.
So there is a methyl, yes, you're right here. And what about on the other end?
That is a hydroxyl.
So you said it on the last one. So we have a hydroxyl, but we also have
carboxyl.
yes, good. Carboxyl, because it has the carbonyl group that's double bonded with the oxygen, and then we have this hydroxyl group. So together they make the carboxyl group. Okay. So lipids are nonpolar and hydrophobic, usually. Why is it that oil floats on top of water and does not mix with water? Why is that?
What floats on top of water?
Oil floats on top and does not mix with water. If it's nonpolar, then it's right. It doesn't mix with water, so that's why. So they're not water soluble. Okay, so let's go to the next one. So we see our carboxyl group and our methyl group. Good job on that. So the next one is proteins. So the critical component of organ and tissue also, not just muscle. So yes, our muscles are made of proteins, but they're also made of, we also have a lot of components in our organs and tissues that require amino groups and proteins. Yes. So where's the amino group?
NH2.
Right there. And we also have this one that we also have the carboxyl group, right? Or amine or amino, yes. So this is tryptophan. This is an amino acid. Okay, now we are getting into the structure of DNA. Nucleotides make up DNA and RNA.
Those the bottom, those are hydroxyl.
Right, this has several of what we've been looking at. These have several functional groups. So you found the hydroxyl.
Are those phosphates on the left?
Yes, these are phosphates. And what about that?
That is a amino.
Right, an amine or amino group. Okay, so we have the amine that's in the base, and we'll talk about, that's another lesson when we get more into biochemistry. So we have the amine on the base, the hydroxyl and the sugar, and the phosphate group. And that's what makes up nucleotides, which make up DNA and RNA. So write the name of it on your board and show it to me. we'll move to the model kits for your summative assessment to know that you really understand this. So let's do
Is that it?
and let me redraw that a little better for you, a little more realistic. Right, and an amine or amino group. Okay. So now we're gonna use the kits. So we're going to model these using these molecular model kits. There is a key on the lid that tells you what each of these balls stand for, which atom. So carbon is black, oxygen is red, hydrogen is white. These gray ones are the bonds that you're going to use. So I want you to form two molecules. I would like for you to form a methyl group.
Can I see a key?
The key is on the lid. Yes.
Where's the lid?
Oh, sorry. Here is the lid. Okay. So I want you to form a methyl group. Okay? A hydroxyl. And an amino
Let me go.
or amine.
I'm gonna go on.
Just one at a time.
This is not full.
Okay, so let's see your methyl group. Good. So show me which atom is which.
This is hydrogen and this is carbon.
Right. So carbon and 3 hydrogens. Good. Now let's do a hydroxyl group. Oh, here we go.
So to be like that.
Mhm.
Yeah.
Okay, good. You included the methyl group in it too. So you have show me exactly where the hydroxyl group is.
Not these, just these.
Just the oxygen and the hydrogen. Good job. All right, one more. So find what nitrogen is, that amine.
Wait, what am I doing?
So you're gonna do the amine. Okay.
Yeah, what would be stand at, or never mind. This?
Yeah, so you're gonna have one more,
There's no-
bond.
But there isn't.
Okay, that's fine, yes.
What is it? What's the other
It's
one?
NH2 is your amine group.
No, what is R stand for?
Just another functional group.
So
So you got it right, yes. All right, good job. Do you see how these functional groups stay together and they are essential to the functioning of the human body because they are in the macromolecules that make up our human body? Okay, all right.